Hey folks, today we're going to be talking about Lewis dot structures. I hope you're excited. Let's get it. One thing I wanted to say before we get started, this is only for covalent molecules because today, Lewis dot structures, we're going to talk all about how they share electrons. Okay, so we'll first start with drawing Lewis dot structures. First thing I want you to know, there are 8 different types of Lewis dot structures, and I have drawn you one of each here. You'll notice that some Lewis dot structures have a letter with one dot. Some have multiple letters. They either have one or multiple letters, and they have somewhere between 1 and 8 dots. So my question for you is, what do you think these dots represent? Pause the video if you need more time. Here's what they represent. Valence electrons. What? Okay. So you'll notice that hydrogen over here has 1 valence electron. Helium over here, it's got 2. Rest of these guys over here in the noble gases, remember they all have 8, and then it goes 3, 4, 5, 6, 7. This is only for covalent molecules, so notice we're kind of skipping over most of the metals. We're not going to really talk about metalloids. We're really only going to focus on those guys in yellow, the non-metals. So there's hydrogen right there. It's in group 1. It has 1 valence electron, 1 dot. Kind of awesome. Helium over here, it's got 2 dots because it has 2 valence electrons. Boron's got 3 dots. We won't really talk about it because it's a metalloid. It won't really form covalent compounds. And then carbon's got 4, nitrogen's got 5, oxygen's got 6, fluorine's got 7, and neon's got 8. So that's actually the first question on your homework for today. What do the dots represent? They represent valence electrons. So yeah, hopefully this makes it nice and clear. I spent a lot of time on this, so I hope you get something out of it. Yeah, so this is something I'd write down with Lewis dot structures. The dots represent the number of valence electrons, not the total number of electrons, the number of valence electrons. Those are the guys on the outside, right? Yeah, so just like here, you can kind of see how everything has its number of valence electrons. One other thing, I don't know if I said this already, helium and neon are both noble gases. They won't react, so we won't really worry about their Lewis dot structures. Boron is a metalloid, won't really react. So usually we only deal with things that either have 1 valence electrons and then those that have 4, 5, 6, or 7. We don't deal with 3 and we don't deal with 2 or 8. So here are all of them. We're going to get rid of helium, boron, and neon. They don't form covalent bonds because they're noble gases. Noble gases are unreactive. And boron is a metalloid. Only nonmetals are going to form covalent bonds. So we're really dealing with hydrogen, carbon, nitrogen, oxygen, and fluorine. Let's talk a little bit more about these guys. Now, remember, they all want to share, because this is a covalent bond that we're talking about. They also all want to be happy and stable. And remember, stability comes when you have 8 valence electrons. For fluorine, it's going to need 1 extra electron. Oxygen's going to need 2. Nitrogen's going to need 3 extra. Carbon's going to need 4 extra. And hydrogen, remember, hydrogen's weird. It's closer to helium, so it's only actually going to need 1. Hydrogen's kind of the exception to the rule. Write that down. Hydrogen, exception to the rule, only needs 2 valence electrons to be stable, kind of like how helium is stable with 2. So, anyways, what I wanted to show you then is how this thing called bonding works. So, when we want to show that 2 atoms are connected to each other, instead of drawing another dot, we're going to draw a line connecting the 2 dots. What that'll look like if you're just kind of focusing on these individual elements is this. Hydrogen will have 1 bond coming off of it because it's got 1 dot. Another bond gives it 2, and it's stable. Carbon's going to have 4 bonds coming off of it. Think, it already has 4 dots, and then with each bond, it gets an extra electron. So 4 dots plus 4 bonds is going to bring it up to 8. Nitrogen over here is going to form 3 bonds. It's got 5. 3 more lines is going to give it a total of 8. Oxygen is going to form 2 lines to get a total of 8. And fluorine is just going to form 1 line to get that 1 extra electron. Neon and helium both don't form any bonds, and boron's kind of weird. It sometimes forms stuff. That's why we're not going to talk about it. So anyways, here they are. I'm going to take all these lone electrons, all these electrons that are kind of by themselves. If they're doubled up, you'll notice they won't change. Do you see that? Notice how they don't really change. I'm going to take away those lone electrons, just like that, and replace them with lines. So here now you see hydrogen stable with a line. This line represents 2 electrons. Carbon stable with 4 lines. Each line represents 2 electrons. So 2, 4, 6, 8. Nitrogen stable with 8 as well. It's got 2 dots, and then 2, 4, 6, and then the 2 dots are 8. Oxygen's got 4 dots and 2 lines. So again, that's 8. And fluorine's got 6 dots and a line. Again, that's 8 because each line is worth 2 electrons. So yeah, that's kind of one of the fundamental rules. Everywhere you see a lone electron, a bond will form. And that's pretty much everything you need to know about Lewis dot structures. What I want to move on into now is actually forming covalent compounds. So you'll be given a formula like this, something like CH4, and you'll have to, from that, create a structure with an element in the middle and a couple elements around it. That's something we're going to talk about in class today, but here are just kind of the rules, so this is kind of helpful to know. Rule number 1, place the atom that can form the most bonds right in the center. Put that in there. It's sometimes you can also say it as the fewest number of electrons, but that doesn't always work because, you know, hydrogen can never be in the middle. Hydrogen doesn't have enough bonds, right? It can only form 1 bond. But carbon over here, with its 4 dots, can form 4 bonds, which is nice because we have 4 hydrogens. So, first rule, place the atom that can form the most number of bonds in the center. Boom, you do that. And then what you do for step number 2 is give each atom its number of valence electrons. So you'll notice that carbon's got 4 here, and each hydrogen has 1 because hydrogen has 1 and carbon has 4. I know this can be a little bit confusing, so hopefully these 2 steps make sense. We put the atom in the center that can form the most number of bonds, and then we just put every other atom around it, and then we're going to give each atom its number of valence electrons, and then the third step is going to be connect the dots, right? So each hydrogen wants to form 1 bond, and carbon wants to form 4 bonds. There are 4 hydrogens, there's 1 carbon, so carbon can form 4 bonds to each hydrogen. And then notice how now each hydrogen has 1 bond, so each hydrogen's got 2 electrons, and carbon here has 4 bonds coming off of it, so carbon is acting like it has 8 electrons, which is nice. Carbon wants 8 to be stable, hydrogen wants 2 to be stable. And then the last step here is kind of what we just did. We check to make sure that all atoms have 8 valence electrons. I should put a little except there, except hydrogen, right? Hydrogen only needs 2. But yeah, that's how you draw a Lewis dot structure. So if I could break it down for you, what I would do is I would say that there are really 2 rules. Rule number 1 is that everything needs 8 valence electrons. And rule number 2 is there is a total number of electrons that you can have, right? We only can give each hydrogen 1, and we can only give carbon 4. So our total number of electrons here is really just 8. So yeah, those are kind of the 2 main rules, is give everything 8 valence electrons, or in hydrogen's case, 2, and then make sure that you don't put more dots than you need. Okay, so we'll go over this in class, and this is kind of just drawing some Lewis dot structures, but I wanted to show you kind of what these Lewis dot structures look like. So I'm going to give you the answers, and then when we're in class, we'll actually talk about how to do these. Here they are. Here's phosphorus with 3 fluorines around it. Here's sulfur with 2 chlorines next to it. And here's carbon with 2 fluorines and 2 hydrogens. Okay, hopefully this makes sense. We'll do a lot of practice with this together so that it'll make more sense as you kind of see it happen. Thanks for watching. Have a great rest of your day.